let's look at systems of equations and solving them using by graphing. Alright, first, linear equations, remember, is an equation in which a graph of its solutions consists of points that lie on a line. So we're going to look at lines. Now, a system of equations is a set of two or more equations with the same variables. So you'll have like an x and a y or a and a b in both equations. Alright, so the one point in which all the equations in the system intersect is the solution to the system, and we're going to write that solution as an ordered pair. Alright, so let's look at some examples. So the first one is graphing the system of equations. So I have y equals x plus 4, and I have y equals negative 2x minus 2. Now, if you notice this one, x plus 4 is right here. Notice that it intersects here at negative 4 on the x-axis and at 4 on the y-axis. And then when I graph negative 2x minus 2, it goes the opposite direction. Notice they hit at one point. This intersection is going to be the solutions to this system. So these two graphs hit and intersect at negative 2, 2. So this is your solution to your system of equations. Very easy. Alright, let's look at another one. Okay, one where we have 4x minus 2y equals negative 6. And we have 2x minus y equals negative 3. Now, here, notice in both of them, they're not in slope-intercept form. Now, you can use any way you want to graph them. I always like using slope-intercept form. So, I'm going to solve both of them for y. Notice when I do that, I have y equals 2x plus 3 in this equation. Here, I also have y equals 2x plus 3. It's the same equation. Since it's the same equation, it's the same line, and your solution actually is going to be all solutions, because any point on this line is going to be a point on both this line and this line, since they're the same equation. Now, what if you have something like, and we're falling down, okay, 3x minus y equals negative 4, and 3x minus y equals 0. Okay, let's first put them in slope-intercept form so we can compare them. This one, I'm going to subtract 3x from both sides. I have negative y equals negative 3x minus 4. Then I'm going to multiply this side by negative 1 to get rid of that negative and this side. And I get y to equal 3x plus 4 is my answer. Or not my answer, but the equation in slope-intercept form. So let's do this one. Again, subtract 3x from both sides. I have negative y equals negative 3x. And again, multiply each side by negative 1. And I have y equals 3x. Alright, and notice I have nothing plus or minus. Notice these two slopes of these lines, they're the same. Okay, that means way back in the last chapter when we talked about parallel and perpendicular lines, remember those slopes were the same if they were parallel. These two lines have the same slope. Therefore, when you graph them, your lines are parallel. And the definition of parallel lines is that they never intersect. They're always going to be running parallel with each other. So, your answer here would be no solution. Now, let's kind of review what we just learned. So, we have different types of graphs, okay? We can have intersecting lines. Perpendicular lines are just lines that intersect. Okay, you're going to have one solution with those if they just intersect. Now, if they're the same line, same equation, you're going to have infinitely many, meaning all the points on that line are solutions. So your answer is going to be infinitely many. Now, if you have parallel lines, your solution to that system is going to be none, because they're never going to intersect. You're never going to have a point. So remember this type of line you get and how many solutions you should have in your problem.